Hi guys, try to finish up within the next couple of minutes, please. Okay, Amanda, if it's okay with you, we're gonna start going over the questions just so we make sure that we have time to get through everything. Okay, great. So the first question on the practice was asking you to make a method that returns an array containing all of the duplicate values. So I'm going to share with you guys how I did this problem, and there are multiple solutions, but this is just how I decided to do it. Okay. Can you guys see my screen? Okay. So this is my find duplicates method. So the first thing that I did was create an array list called duplist, and that is going to be the array, sorry, not array list. That's going to be the array that the method returns containing all of the duplicates. And so in terms of its size, I just initialized it so that it had the size of the original list that was passed in. Because you don't know exactly how many duplicates there are going to be in the array, but you know that there can't be more duplicates than there are elements in the original array. So then I have another variable that I have initialized to 0. And this is going to be the variable that moves us through this duplicate list. So every time we find a duplicate element, we're going to add 1 to count so we know where we are in that index. So then I have this first for loop that is going to go through all of the elements in list. And then inside of that for loop, I'm going to have another nested for loop. And this is going to go through all of the elements after the current I that you're on, so it's going to move sort of one step ahead. And basically what we're going to do inside of this nested for loop is we are going to check if this first variable I that we're on, if this element is equal to an element that we find later in the list, which is what J is counting, then we're going to add it to our duplicate list. And so then I just created another method called contains. And you don't have to do this, but this is just, like I said, this is how I decided to solve the problem. And basically what contains is checking for is to make sure that we aren't adding an element to the duplicate list more than once. So for example, if we had a list that had multiple ones, what contains is going to do is if we already added one to the list, when we get to another one later on and this inner for loop tries to add it to the duplicate list again, this method contains is going to check to see if one already exists in duplicate list. And if it does, then we aren't going to add it again. So all that the contains method is doing is it's going through our whole duplicate list and it's searching to see if the number that we want to add to it is already there. And if it is already there, then we are going to return true. Otherwise, we are returning false. And so if duplicate list doesn't already contain the list element that we want to add to it, then we're going to add that element to our duplicate list array in the index of whatever our count variable is on. And then once you add an element to it, you know that you have to move your count variable up. And then at the end of this method, we're going to return our duplicate list. Does this make sense to you guys, or do you have any questions? Okay, great. So I have to get going now, but Seven and Jack are going to take you guys through the other problems. I'll see you guys later.
Okay, so I'm going to walk you through the second problem that we covered today. So for the second problem, we asked that you find all the, or remove all the duplicates from an array. So let me go ahead and share my screen with you. Okay, can everyone see this? Okay, cool, perfect. So for remove duplicates, we gave you a few examples just so you knew what to expect. So for example, if you were given the array like 5, 2, 7, 4, 5, 8, maybe like 7, this would return the array with all the duplicates. So the 5, 2, 7, 4, 5 would, oops, my bad. 5, 2, 7, 4 would be there. The 8 would be there, but this 5 wouldn't be here and the 7 wouldn't be here. So it'd just be 5, 2, 7, 4, 8. So we have, this one is probably seem like the trickier one from the mix. So right now we have the method signature. And if we're going to go ahead and write this method, the first thing we want to do is we want to create kind of a new array that's going to be essentially the old array, but without the duplicates. So I'm going to call this array like remove. And it's going to equal a new int array, but the length of this array we want to set to the length of our current array. And the reason for this is our current array passed in may not have any duplicates at all. And if this is the case, then remove should just be exactly what's returned. Or it would be the current array, and remove would then equal it. However, we don't know if it's going to have one duplicate or two duplicates or exactly how many elements we're removing from our original array. So instead of trying to resize our original array each time, we can just approach the problem by setting remove to be the original length of the array. So for example, if we were going to draw this out, given our example up here, we would have a new array, length 1, 2, 3, 4, 5, 6, 7. Oops, sorry, this is really messy. And then as we're removing them, essentially what our goal is, like, we're going to check to see if 5 appears in the rest of the array. What we're going to try to do is check to see if any 5s come before the 5 we've already have. So when we get to the 5, we haven't seen any other 5s previous to this. So we're going to add it. Same with the 2. Well, 5 is not equal to 2, so we're going to add it here. Same with the 7 and the 4. And then once we get to this 5, when we look through the elements we've already seen, we see that we already have a 5. So we're not going to add it. And we're going to go straight to the 8 and add it. And again, when we get to the 7, oh, well, we've already seen a 7 before, so let's not add it. And we're going to then remove an array with these 5 elements in it. So that's just kind of an overview of the approach to solving the problem. And then we can go ahead and write that in code so you guys get a good understanding of what's happening. So that's so the reason why remove is equal to array.length is because if this original array had no duplicates, it would be the same length as before. The next thing we want to do is we need to keep track of what spot we're adding to the new array. Because our index in our original array might not always be the same as the index of our new array, we need to keep track of the new spot. And we're going to start that at 0 because, again, remember that all arrays index start at 0. After this, what we're going to do is we're going to have a for loop starting at 0. Oops. I'm going to use A instead of I, so it doesn't always try to capitalize it. And so we'll start at 0, and then while A is less than array.length, similar to what Hannah did in her example, A++, so we look at all the elements in the array. And while we're in here, we want to make sure we look at all the elements that came prior to see if that there is a duplicate or not. So what we can do for this is have another variable, b equal to 0, and go while b is less than a, b++. So what this is doing is it's looking at all of the elements that we've already seen that came before this one. So for example, let's pretend we're at this 5 right here. Our A value, or what index this 5 is at 0, 1, 2, 3, 4. So A here equals 4. But our B value would only equal however many elements we've already added. So 0, 1, 2, 3. Well, oh, I guess our B value would equal 4 because ultimately we're going to increment it to the next place to add. However, if we look at maybe the 7 back here, well, this would be spot 5, 6, so A would equal 6 here. Our B value would equal whatever this index is right here, which would actually only be 5. So here our B value would equal 5. So these values might not always be the same, and because of that, we're going to have spot as a separate variable, and we're going to just use B to keep track of. Oh, sorry, I've been explaining the wrong thing. My bad. B is going to represent all the elements before that need to be checked. Did that make sense? Sorry, I know I was explaining the wrong thing for half of that. So essentially what B does is B checks that, if we're looking at element 7, B, make sure that we check all these elements that came before it to see if a 7 has already passed. And so, for example, if we're looking at element 8, maybe, we'll look at all of these elements to see if an 8 has already passed when we check for duplicates. Does that make sense? Okay. Sorry about that. I know this one's got a couple of different parts to it. Once we have set up our 2 for loops, we can then check to see if the array at element A is equal to the array at element B. And if these two are the same, so if we found that the element we're currently looking at, for example, if we're currently looking at 7, has already come before, then we should not add it to the array. But if for whatever reason these two things are not equal to each other, then we should add it to the array or to our remove array. So a remove at index spot would equal array at index A. And then it's very important that we increment our spot counter so we don't just keep adding things to the first element. We can do that by spot plus plus. So at the end of these 2 loops running, what we should have is we should have created this second array down here. However, we don't want to return an array with a lot of white space at the end. Ideally, the array we would return would only have these 4 spots in question, or these 5 spots. 5, 2, 7, 4, 8, and no white space at the end. So at the end of our code, what we have to do is we have to go through our remove array and make a new array, essentially, without all those white spaces. So we can do this by creating another array. We can call this one maybe toReturn, and set it equal to a new int array with length of spot. The reason why length is going to be spot is because spot refers to the number of elements added to the array. Because every time we add an element into our remove array, we increment spot. Spot not only duplicates as a or represents the placement of where we need to add, but at the end, it will also represent the length of the number of elements in our remove array. So once we create our toReturn array, we can create an incrementer that goes through our remove array. So this can either be spot here or toReturn.length. And what we're going to do is we're going to increment through our array, and we're going to set toReturn A equal to remove A. And while remove originally had all those white spaces at the end, toReturn is not going to have those. And then so here at the end, if we just return toReturn, we have the array without any duplicates and no white spaces at the end. Does that make sense? Are there any questions about this example? If you do if array A does not equal array B, won't it add numbers to the array without checking all the way? Ooh, good catch, Amanda. That's exactly right. We don't, I messed up here, and we don't actually want this if statement in this spot, but rather we want to keep track of a temporary Boolean variable. So like, for example, we can call this Boolean variable found. And found, we can either go like that because found automatically equals false by default, or we can set it equal to false just to make it extra clear. So if array A equals array B, we will just set found equals true. And then at the end, once we've gone through all of the elements we've already seen before, here we have our if statement. If not found, then we want to do that replacement. Good catch, Amanda. So remove spot equals array A. And then, of course, we have to increment our spot. So spot plus plus. Nice catch. Does that make sense, Shreya, as to why we have to do that? Oh, okay. And then does anyone else have any other questions? There we go. Now we can see the whole thing. Awesome. So yeah, now I'm going to pass it off to Seven then to go over the histogram example. Wait, Seven, I can't. Are you talking? I can't hear you. I don't know if anyone else is having that issue.
Can you guys hear me now?
Yeah, you're good.
Okay, I'll just use it without my headphones. Okay. Let me share my screen real quick. Sorry, it's taking some time. Okay. Can you guys all see that? All right. Amanda, did you have a chance to look over the question for this part? Because I know Shreya submitted an answer. Okay, sounds good. So you guys both understand what the question is asking for, right? All right. So, there are like many ways to write this, but I will try to write it in one of the most simpler forms. So first, we have to create a to return, or I guess to update the values, and then we can call this histogram. And then we, do you guys know what we initialize this to? What number we should put in there? Yeah, so when I was writing this example, I put in 5 and I kept getting errors, and it was just like a stupid mistake. I didn't understand why I kept getting an error. But basically, because we want, or we're given an array of numbers from 0 to 5. If you include 0, you actually have 6 numbers, so you want 6 element array. So basically, you create a histogram array with length 6. And then what you want to do is you would want to look through each element of the passed in array. And we do that using like our regular for loop, which is just for and I. So we look through the array, and then what we want to do is for every element and histogram that corresponds to the, or for every element in the array ARR that corresponds to the index of histogram, we want to increase that number in that index by 1. Okay, that sounded very confusing, but basically if you look at the histogram array right now, currently you have 4, 5, 6. This is what your histogram array looks like, because when you first initialize it, Java initializes your integer array to be 0. You guys all get that? So far, so good? Okay, so to make it easier, I will just create another variable called check, which I'll just set it to like -1. That's just like a placeholder. So basically, we're gonna set our check num to the each element of the array, of passed-in array. So for example, if we have an array of, so this is histogram, and then this is our R. Basically, when I equals 0, this whole thing equals 1, right? And what we want to do is we want to look for the index 1 in histogram. So in histogram, for index 1, which is currently stored in check num, we just, all we have to do is we just increase that by 1. It's just plus plus. It's just like a counter by 1. And then if you continue running through this for loop, this I becomes 1, and then the element in your first index is 2. So you change that to 2, and then this check num equals 2. So basically it goes to the 0, 1, 2 second index of your histogram, and then it increases by 1. So like that. And then at the end, you just return histogram. And then, so in main, I have first array with 1, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 5, 5. And then I called the method get histogram by passing in this array. And then I stored the return value to answer 1. And then if I print this one out, so if I print out the values for answer 1, I should get this array, which you can see I have right here, 0, 1, 2, 3, 4, 5. And then same thing for this example, I created another array of just element 0. And then if I run this, I should get something like this. Actually, one more element. And yeah. Any questions about this example? Okay, so that is basically all we have for you guys today. If you guys have any other questions, specific questions, you can always sign up for a one-on-one. Yeah, for one-on-one tutoring, and I'll give you the link to that. There you go. Yeah, you can just go ahead and submit the form because we use the form to keep track of the attendance. So that'll be helpful for us. Thanks for asking, though. So this is the link to the calendar. You guys can sign up anytime. You guys can always give us an email for any other questions. And yeah, thanks for coming today. Have a great week, guys.